Welcome. In this video, we are going to begin our study of graphs. So graphs are one of my favorite topics. They're actually what I spend a lot of my time thinking about when I'm not thinking about teaching. I love graphs, so let's talk about graphs. And I'm excited to talk about graphs with you. So what is a graph? A graph is an abstract model of a connected system. It's kind of the simplest mathematical distillation of the idea of connection, stuff being connected to other stuff. If you want to get the simplest possible representation of the idea of stuff being connected to other stuff, you want a graph. So we care about stuff that's connected to other stuff in a lot of different settings. So here's one example. Social graphs or social networks. So on the right-hand side, I've shown a picture of a pretty famous social network of social interactions between high school students in a French town that researchers often use to kind of study, hey, how do people make social connections and what happens once they're made? So we can study social graphs or social networks on relatively small scales like this one or on massive scales of millions or billions of people. So sometimes people are connected to each other. Other times, stuff in the physical world is connected to other things. So here's an example. Towns and cities are connected to other towns and cities in every country by road networks. So here, what's being connected is a location, and the thing that's doing the connecting is a piece of road infrastructure. And then finally, and this is often especially important in computer science, we use graphs quite frequently as data structures. So we have data that is connected to other pieces of data, often in structures like this tree here. So we can think of each of these little red dots as a piece of data, and that piece of data points to some other piece of data that we might need to access next. And many important data structures have this kind of connected structure that we can represent as graphs. So in this set of videos, we are going to learn to define graphs. We're going to build some basic mathematical theory of how graphs work, of different kinds of graphs, of some of their properties. And then we're going to go deeper, especially into the very important type of graph trees in our next series of videos. Let's formally define what a graph is. So mathematically, a graph is really two things. So in this class, we're mostly going to focus on undirected graphs. So when I say graph, I mean an undirected graph. And what an undirected graph is, it's a pair. So we call the graph G, and the graph G is a pair of two things, V and E. V is the set of vertices, V for vertex, although, warning, we often also call the vertices nodes. Vertex and node means the same thing. V is a set of vertices, so you can think of this as the things that are being connected to each other. Then E is a subset of, okay, what's this set here? This is the set of all sets of size 2, containing two elements of the vertex set. So the set of all subsets of size 2. E is a subset of this set, and that just means E is a set of subsets of vertices of size 2. So we can think of it as a set of pairs of vertices. So what does this look like? We often draw these objects. This math definition is kind of dry, but we often draw them. So here we are. So in this picture, okay, my node set is these 5 pink nodes here. And then my edge set is represented by these gray lines connecting the nodes. So each of these edges connects exactly 2 nodes. It's a subset of the set of all the possible nodes. So one important little point here is that in this definition, pairs of nodes, we haven't actually specifically ruled out the idea that the node could be the same in both cases. Indeed, an edge here from a node to itself So remember, sets don't have duplicates. So really, this is the same as just the single set containing U. And this is called a self loop. So a self loop looks like this. It's an edge joining a node to itself. Self loops are interesting sometimes, but they're not very useful most of the time, and we won't use them in this class. And so when we talk about our edge set, we're always talking about edges that look more like this, that join two distinct vertices to each other. Now, one more important point here is that remember, sets don't have an order. U and V is the same set as V and U. And so what that means is that if I have an edge, let's say A and B, and another edge B and A, where A and B are vertices, these are actually the same edge. So the order doesn't matter. The edge A and B is the same as the edge B and A because sets don't have any order at all. These edges are the same edge. There's no distinction between them. If we want the order to matter, then we need a directed graph. And a directed graph is a graph in which instead of having the edges just be lines, we actually have edges represented by arrows from one node to another. This is an important idea, but not what we're going to be talking about today. So formally, big picture, a graph is a pair of two things, a set of vertices and a set of edges. The vertices can be anything we want, although usually we give them just labels like U and V. And then the edges are just collections of pairs of vertices. And not only can we define this mathematically, but we can also draw it. We draw little dots for our vertices and little lines for our edges, constructing our graph.